Hi guys, in this video we have to find the pivot element in the sorted and rotated array. Okay, so what is pivot element? What is sorted and rotated array? I will explain all of the things. Okay, let's say we are having this array. This array is sorted and rotated array. This array is called as sorted and rotated array. Why? Why? Because let's say I'm creating array 1 to 12, 15, 16, 19, 21, 23, and 24. Let's say I am having this array. You can see this array is sorted. This array is sorted. Okay, so sorted. If we rotate this array by 3 number of times, so what will be our resultant array? 15, 16, 19, 21, 23, 24, 1, 2, and 12. And you can see this array is exactly same as this array. That means this is sorted and rotated both. Okay, so how we have to find the pivot element in the sorted and rotated array. So what is the pivot element? Pivot element is the smallest number, the number through which the array is rotated, and we all know that the smallest number will be always present at the first index of our sorted array. Basically, what we have to do, we have to find this element, this element. We have to find the element from which the array is rotated. An array always rotate from the first index, and first index is the smallest element in a sorted array. That's why we have to find the minimum element in the array. Simple. Simple. What we have to do in this question, we have to find the minimum element. Okay, now you will see that there are so many ways of doing this question. Firstly, sort this array. Use any sorting algorithm, sort this array and return the value present at first index. This is the first solution. Second solution, traverse the whole array and find the minimum element. This is second solution. Third solution is what I am going to teach you. This solution includes some tricky methods. How we are going to use two pointers to get this value. We will use two pointers to get this value. I will explain you how we are going to use them and how we will get this value. Basically, the final result will be both of the pointers will point to this value. And at that moment, we have to return that value. Okay. Now, let me define a region. There will be a region from low to high. Okay, and in this region, every time in this region only we are going to perform our actions. In this region we are going to perform our actions. Initially this region will be low to high. That means initially we have to perform our actions in the whole array. That's why we have taken low as 0, high as the index size -1. Okay, now what are the actions we have to perform? Basically, at every iteration we have to remove the part of the array which is sorted, because we are going to find our answer. This is our answer. We are going to find our answer in the part which is unsorted, which is non-sorted. How? Let's say if if I divide this array, from this part. Okay, in which part would you like to do our further executions? In this part or this part? In which part you would like to do our execution? Of course, this part, because this part includes 1, and this part is sorted. The part which will be lefted will be always sorted, always. Okay, so what we have to do? We have to find which part is sorted and just remove that. Remove that means we will shift our region low and high. We will shift our region accordingly. Okay, now let's start our execution. Okay, now I will ask you something. Okay, I will ask you something. You have to answer. If I write this condition array of, before writing this condition, let me find the mid of this array. What will be the mid? 0 plus 8 by 2, that is 4. That means mid will point here. Mid will point here. Okay. Now I am writing the condition. If array of mid, okay, array of mid is greater than array of low. What this line is representing? What this line is representing? You can take this example. Array of mid, that is 23, is greater than array of low, that is 15. Yeah, this condition is true. What this condition is representing? This condition is representing that the part between low and mid is sorted. This part is representing the part between low and mid is sorted. And if I write another condition, array of mid is less than array of high. If I write this thing, then what this thing is representing, this part is representing the part between mid and high is sorted. The part between mid and high is sorted. Okay. So we will use these two conditions. Simply we will use these conditions and we will shift low and high pointer. Low and high pointer. Understood? We will shift low and high pointers accordingly to that part which is not sorted. Okay. This is all about the theory part. Let me do some executions. Okay, let me do some execution. What I will do, mid is here, high is here, low is here. I will write if, I will check if array of mid is greater than array of high, not greater than, lesser than. If this part is true, that means mid part is lesser than high. That means the part between mid to high is sorted. So what I have to do? I have to decrease my region. Low will remain here, and I have to shift my high to mid. So what I will do? I will write high equals to mid. Simple na? In this case, you can see array of mid is lesser than array of high. Array of mid 23 is lesser than no. I will write another condition. This condition will do all the work. What I will write? I will write L if array of low is lesser than array of mid. Lesser than equals to. Okay. If this condition is true, that means the part between low to mid is sorted. I have to shift my low to the next of mid. What I will do? I will write low equals to mid plus 1. Simple. Because yeah. In this case, mid is 23. Low, high is 12. Is 23 less than 12? No. So this condition will not execute. Another condition. Low is 15 less than 12. 23. Is 15 less than 23? Yes, 15 is less than 23. So what we will do? We will shift our low. To this point. Mid plus 1. Why mid plus 1? Why not mid? You can ask na, why mid plus 1? Why not mid? We have to find the smallest element. And array of mid is greater than array of low. So can our answer be array of mid? Let's say array of mid is in this case 23, low is 50. Okay, if I shift my first, if I write this first equals to mid, is there any sense of writing this? Because mid cannot be our answer. Because mid is already greater than low. Mid cannot be our answer. So why to include that mid into our region? Why should we include that mid into our region? That's why we are excluding all the part from low to mid, and we are including the part mid plus 1 to high into our array. Understood? This is why I am writing mid plus 1. Okay. Now This is our part. Let me remove this. You understood now why we are writing mid plus 1? Why we are not writing mid? Because mid is already greater than low. So why should we include this mid into our region? That's why we have excluded this. Okay. So this is our new region. This is our new region. Let me remove this. I'm just removing this to simplify our look. Okay. Now low is here, high is here. Okay. This will be, let me remove this indexing, 0, 1, 2 and 3. 3 plus 0, 3 by 2, 1. Mid will be at this point. Okay. Now we will check. Now we will check is if array of mid, that is 1, is less than 12. If this is true, that means the part between mid and high is sorted. Mid and high is sorted. Okay. So what we will do? We will simply shift this high to mid. Shift this high to mid. This will be our high. Okay. Now low is here, high is here. This is 0, this is 1. Let me remove this. Okay. Now 0 plus 1 by 2, that is 0. Now mid is at 0. We will check our condition. If array of mid is lesser than high, array of mid is 24, array of high is 1, 24 is less than 1, no. Else we will check our condition. If array of low, that is 24, is less than equals to array of mid 24, yes, that means we have to increase. We have to write low equals to mid plus 1. Mid is 0. So what will be our next point? Just remove this. What will be our next point? Our low will be shifted here and this part will be removed. And I said earlier that when both of the pointers will point to a single index, that means that will be our answer. So you can see high and low are pointing to 1. 1 is our answer. So this is how we are going to proceed the question. Okay. So let's write the code and submit it. Okay. Now what I have to do? I have to create 2 pointers. Low, which is at 0, high, which is at last index. Last index means length of array minus 1. Simple. I will run this loop while low is not equals to high. Simple. As I said, when both will become equal, I have to return that answer. Okay. What I will do? I have to check if array of mid is lesser than array of high. If this is true, that means the region between mid and high is correct. So what I have to do? High equals to mid. Simple. If this is not true, then I have to check array of low is less than equals to array of mid. If this is true, that means the region between low and mid is sorted. So I have to shift my low to mid plus 1. Understood? And at one point, these all low and high will point to a single index, and we have to simply return array of high or low, anything, because both are pointing to a single index. Okay, so we are having runtime error. Let's resolve this error and check what's the problem in this. Find pivot, array of mid, high. Let me see this. Okay. We have not created mid. So what I have to do? Mid equals to low plus high by 2. Simple, na? We have not created mid. That's why it is showing us error again. Okay, what is the problem? Array while if mid equals to, let's debug this code. I know our concept is correct, our logic is correct. There is some syntax error. Let me resolve this. Okay, so we have to convert it into int. Okay, because this will provide us floating value. Now this is accepted. Understood, na? We have to debug the code what we are facing a problem low plus high by 2. Let's say 2 plus 3 by 2. So 3 plus 2, 5 by 2, it will give us 2.5. This is not an index. We have to get the answer 2. We are required indexing 2. That's why we have converted into int. Okay, so this is all about this problem. I hope you guys understood the video. We will meet in the next video. Until then, bye.